So, hello together, warm welcome to all to our webinar Wednesday today. Today we have a new member of the Composite Unite Toyota Industries, and Hiromasa Tomioka will present a new development of Toyota Industries, recycled carbon fiber yarn and what they have done. And we are really interested what in Japan happens in the last years. And yeah, the stage is yours, and we are looking forward to see your presentation.
Okay. Good morning, everyone. Thank you for the introduction, and many thanks to Composite United for the opportunity to present today. And Toyota Industry is a company that mainly manufactures logistic equipment and automobile parts. We have an R&D team at our headquarters focused on composite materials. I will provide more details about our company later. And as for me, I'm Hiromasa Tomioka, a project manager for recycled CFRP applications. I have been working with Toyota Industries for more than 15 years, and most of my career has been based on composite materials. Today, I am going to talk about our recent R&D activities that contribute to sustainability. And specifically, I will cover our 100% recycled carbon fiber spun and its applications. And here is quick overview about today's presentation. First, you might be wondering why Toyota Industry is involved in the R&D for carbon fiber recycling technology. I will begin with a brief introduction to our company to give you some background. And next, you may have already known well, but I will address the situation facing the CFRP industry for your reminder. And finally, I will discuss our development in recycled CF material, focusing on recycled CF spun. And I'd like to introduce our company's vision briefly for the first slide. We have a corporate creed that is common within the Toyota Group. We are always thinking about contributing to society by making innovations. And this slide shows who we are and where we come from. First of all, many people get confused between our company and Toyota Motors. We are a different company, but under the Toyota Group. Our company started with manufacturing automatic loom in 1926. We expanded our business and started spinning frame production around 1930. This is start of Toyota Group, which means Toyota Group has a roots of spinning and textile industries. Around 1930, Toyota Industry set up automobile division and then separated. It became the Toyota Motors today. And these companies consist of today's Toyota Group. And this is our corporate profile. Our company was established in 1926 as a manufacturer of automated textile machinery. Our business activities now involves manufacturing and sales of textile machinery, automobiles, industrial vehicles, as well as providing logistics. We have now about 70,000 employees worldwide, over 30 countries. And this chart shows our net sales by business segment. As you can see in the chart, we continue to have the textile machinery sales here, but more than half of our net sales comes from material handling equipment, such as forklifts and logistic business. The rest of our business involves automobiles, which includes air conditioning compressors, engines, and electric parts. And this is our corporate organization chart. Our company has 7 business units: material handling equipment, vehicle, engine, electronics, compressor, and battery and textile machinery. And besides that, we have corporate headquarters. Focusing on corporate headquarters, we have some R&D department, which is where we come from. And these aim to research and develop new products and technologies for all divisions. We come from advanced components development department, and our team is focusing on research and development for textile composites. And from here, I am going to talk about our development. Our company has been developing textile composites for more than 30 years. The development started from a strong request from customers to create 3D textile because the textile technology is our company's origin. Our R&D activities began with the aerospace field with heavy industries companies and expanded to automobile field, mainly with Toyota Motors. We manufactured various prototypes and demonstrators using our weaving technology. Through various projects, we increased our capacity for design to manufacturing process for CFRP. And now we have been able to do the entire CFRP manufacturing process from design to molding with our existing equipment. And recently, we started develop CF recycling, especially focusing on spinning technology, where we originally came from. From the experience of various projects, we learned that overcoming CO2 emission and productivity issue is essential to moving on to mass production. So our development focus is reducing CO2 emission and increasing productivity. To see traditional process, the material itself produce large amount of CO2 emission, and many processes are required for performing. And the molding process itself takes a long time. To deal with this issue, we are developing 3 key technologies: RCF spun and 3D textile and high cycle RTM. In today's presentation, I will focus on RCF spun. Few more insights about our development about recycled CF spun. This video is this is a video which shows you overview of our ongoing activities to sustainability in composite material. Sorry. Sorry.
Just reshare again. That's not a problem. And click forward. Please remember the button. Yeah.
Yep.
We still don't have any sound. Mr. Tomioka, do you want to reshare it again with when you reshare it?
Oh, sorry.
You have to press this little button, remember?
Oh, yeah. Sorry.
That's better.
Yeah, sorry.
Carbon neutrality is one of the social issues that we at Toyota Industries have been tackling. Our 70,000 colleagues around the world continue to take on the challenge of achieving the dual missions of CO2 reduction and decarbonization in each of our businesses. One of the projects we've been working on is the comprehensive CF recycling system. It's an innovative system that enables the recycling of CFRP, or carbon fiber reinforced plastic, which will be essential for the circular society of the future. The virgin CFRP products are high performance, but generates a large amount of carbon emissions in production. In addition, the quality of conventional recycled CFRP products has been weak, which means most of virgin CFRP products end up in landfills after use. To address these issues, we've developed a groundbreaking comprehensive CF recycling system. In developing this system, we harnessed our spinning and textile technology know-how, which is the roots of Toyota Industries, and our simulation technology that brings together the best of the CFRP design engineering we've cultivated to date. The system enables the recycling of used CFRP to produce high-quality yarns while at the same time achieving a significant reduction in CO2 emissions and waste. Our CF recycling system is expected to be applicable not only in the automotive field, which is our main field of strength, but also on a wider scale around the world. We believe the system will greatly contribute to solving the fundamental issues of CFRP. As a pioneer of CF recycling and a recycling platform operator in such a future, we will continue to be studious and creative to remain an indispensable presence in society. Because that's what Toyota Industries does.
Okay, and from now, I am going to talk about the situation facing CFRP industry. As you may already know, but the CFRP market is expanding year by year, driven by aerospace industry, wind power generation, and civil construction sector. This growth shows that CFRP is becoming general purpose material and increasing importance of CFRP in various fields. And CF and CFRP are widely used in many business fields, but have produced significant CFRP waste and that expected to increase. As you know, landfilling is one of the most popular disposals for CF and CFRP waste right now. And only a few percent of the waste is recycled with recyclers. Typically repurposing milled fiber for resin enhancement, chopped fiber as pellet, or transforming it into non-woven fabric. But unfortunately, these methods do not fully recover the potential carbon fiber. And some recycling projects are siloed, which limits its application and scale. To address this issue, we decided to start to establish a comprehensive recycling system, including the development of spinning technology for recycled carbon fiber. And this chart shows how the virgin carbon fiber is recycled. The virgin carbon fiber is collected as dry waste, pre-packaged sheet, or molding parts. These are either recovered by various methods, such as pyrolysis or solubilisis, or dismantled by recyclers to obtain recovered carbon fiber. And that is the raw material for recycling process. As I mentioned in the previous slide, traditional recycling process typically produce chopped material or non-woven fabric, which is randomly oriented. This is cost effective, but we believe that the performance is not sufficient for users. So to maximize the potential of recovered carbon fiber, we utilize our spinning technology, which is our origin, and create highly oriented material. And our product target is that we achieve both CO2 reduction and high performance. We utilize our original technology, such as spinning technology, and align the fiber angle and make the spanium. Using our material, we achieved compatible performance with version CFRP, and CO2 emission is about 80% less than virgin carbon fiber in production. And our goal is to redefine the standards for RCF use and offer a sustainable alternative for CF users. Our RCF Spanium presents an opportunity for closed loop recycling of CFRP, which is recognized an unrecyclable material. This is not only significantly reduce CO2 emissions, but also minimize the waste throughout the life cycle. And moreover, our material is recycled as yarn, so it can be used with the same resin matrix and manufacturing process and equipment currently used for virgin CF in CFRP production. This means that there's no additional investment cost to users. We will open the door to a new recycling cycle for end-of-life aircraft and wind turbines. But when we think about producing recycled CFOP, we have to think about the whole system, because the balance of the amount of waste and consumption and quality insurance is important when we use recycled materials. So we established a comprehensive recycling system with various companies in Japan. What is innovative is that we include the inspection and design tool inside this system. I will explain about this later. And here is our team partners. This system is too huge to build only our company, so we have collaborated with various partners to establish this system. We are the rating organization, and here is 6 core team partners. And in the near future, we are thinking that we would like to establish this system in Europe, because Europe is one of the biggest market in CFRP industry. So we are still open to new partnership and interested in finding new partners, especially in Europe. And I'd like to share our strategy for establishing a comprehensive recycling system. And we have 3 phases. Phase 1 is involved large-scale trials to validate the concept of our CFR recycling system and check the feasibility of the spinning process. And in phase 2, our goal is to establish a domestic recycling group like within the Toyota Group. This includes manufacturing air-jet room parts from carbon fiber waste or CFRP scrap from end-of-life parts. And phase 3 is designed to set up cross-industrial recycling system. And one example would be repurposing automobile CFRP waste for marine parts. We have successfully completed phase 1 and currently focusing on our efforts on phase 2 and 3, and to start discussing establishment of CF recycling system in Europe. We joined Composite United this year. And our material is almost ready to put into the market, and it is a major milestone in our development. But our development does not end here. We are continuously striving to stay ahead of the times, which comes from our corporate creed, and our development focusing on reduction of CO2 emission and enhancing efficiency in production. We believe that continuous improvement is the key to maintaining our competitive edge and delivering value to our customer. And in addition, we are also looking for the feasibility of using RCF Spanian in various projects. The key product is the airjet loom parts and marine propeller. These activities emphasize that we continue making an effort to be innovative with various partners from worldwide to expand the scope of applications for our RCF Spanium. From this slide, let me introduce the details of our activities in each process in recycling system. In the recovery process, we faced the challenge of securing a stable supply of waste. We collaborated with major waste disposer Toyota Motors from the development phase to overcome this challenge. And in the spinning process, we developed 100% pure recycled carbon fiber spanion, and it is compatible with version CFRP performance. When we use this spanion, there's no limitation for yarn count, and we can commingle any fibers such as nylon or PET with any amount. And what is important is that how do we secure its quality? Generally, spanion has uneven shape, making it difficult to ensure the quality. Especially for composite, critical parameter is that fiber length, alignment, and brim fraction. And we updated the production process based on cotton spanion for carbon fiber. To ensure this process, we are collaborating with Uster. Uster is the world's leading supplier of total quality solution from fiber to fabric in the cotton field. And each key parameter is measured in each process with modified equipment for carbon fiber. And this is CFRP performance using our material. We conducted 3-point bending test with like this lamination. The result is that the strength decrease 30% and the modulus decrease 10% compared to version CFRP. And the stress strain curve is here. And the stress in version CFRP goes up sharply, but once breakage start, stress goes down sharply. But as for our material, stress goes up sharply as well, but after breakage, some stress maintain load, it behave like quasi-ductility. And weaving is also one of our core technology because we have 3D textile technology. And our recycled carbon fiber spanion is compatible with virgin carbon fiber in weaving. Our yarn can use an airjet loom with very high productivity instead of rapier loom, which is traditional carbon fiber weaving equipment. Other than weaving, we are trying to manufacture UD prepreg using our spun yarn with our partner. And this is molding process. And here is sample molding parts collaborating with Kurimoto. And we believe that this is the world's first success in adapting recycled carbon fiber for protrusion molding. This success opened the way for high volume production for recycled carbon fiber. And as for weight production, our first demonstration is demonstration of recycled carbon fiber spun yarn has been done within our company. We manufacture the head frames, that is air-jet parts, air-jet balloon parts. And now we are working on cross-industrial recycling as feasibility study by Marine Propeller collaborating with Nakashima Propeller. And regarding to design and CAE, we developed design and CAE tools for RCF spun yarn with Nagoya University and Toyota Center R&D Lab. Our material is completely new, so we have to develop by ourselves. And like other CFRP simulation, we adapt large scale simulation technology for our tools. And our main focus is meso and micro scale simulation, like textile and spun yarn. And for mesoscale, we developed modeling tools for textile, including 3D textile. Our modeling tool can consider deformation in weaving and molding process. And for microscale, we also make a model using a representative parameter in spun yarn. We constructed original constitutive law based on damage mechanics to realize multi-scale simulation. We homogenized it to connect each scale. And now we can simulate what is happening inside the spun yarn and the textile when product break. For realization of sustainable society, we are struggling with enhancing CF recycling technology. And our vision includes the creation of comprehensive CF recycling system, and which is a platform for open participation across industries, inviting collaboration with various companies and partners. Thank you for your time and attention. If you need more details or have any questions about this presentation, please reach out to me. And we will also be exhibiting at JC World 2025. So please feel free to visit our booth. We are happy to have a discussion with you. Thank you very much.
Thank you, dear Hiromasa Tomioka, for this great presentation, and yeah, that you show us, I think, an important step in the world of the recycling of carbon composites, because the separation of fiber and matrix is one thing, but then to make a new semi-finished product out of this is a second really important step, and it's great to see that you developed something yeah, to get a yarn out of it at the end. So thank you again, and now it's time for questions.